shortest path algorithm. So this algorithm is used to find out the shortest distance between the two vertices or two nodes, we can say that. So it is just a shortest path algorithms that we are going to see to find out the shortest distance. So there are some assumptions which we made in this algorithm. So let G, V, comma E be a simple connected graph. Simple connected in the sense there is no self loop and parallel edges. Let A and Z be two vertices of the graph. Means we are finding the distance, shortest distance between the vertices A and Z, which are the vertices from the graph, any two vertices from the graph. Then Lx denote the label of vertex X, which represent the length of the shortest path from vertex A to vertex X. So Lx, we are finding the or we are giving the label to the vertex X, which is present at the length of the shortest path from vertex A. That is nothing but Lx. Then Wij denote the weight of the edge. Eij is equal to Vi to Vj. Means whatever the edge whose terminal vertices are Vi and Vj, and its weight is denoted by Wij. Step 1 in this Discrete shortest path algorithm. So we start from the starting vertex, that is nothing but A. So initially P is the set of those vertices which have the permanent labels. So permanent label, initially no one vertex is given a permanent label. So the set of permanent label vertex P is equal to phi, that is empty. T is a set of all the vertices of the graph G. So T is a set of all the vertices of graph G. Then initially we given a label. So LA is equal to 0. LA is the starting vertex. So starting vertex distance, we find it, that is 0. Then Lx means Ls is equal to infinity for all x which is belongs to set T, and x is not equal to A. Means x, this vertex should not be A, because A label we given a 0, and these are all other vertices whose label is still not given. That's why it is assigned infinity. So for all x belongs to T. Step 2 in this, select the vertex V in T which has the smallest labels. This label will be permanent label of vertex, that is V. So here we are, whatever the adjacent vertex of the source vertex, we will find out the minimum label vertex from the source vertex and we make it as a permanent. So once you make that particular vertex as a permanent, then set of permanent vertex, that is P, will be changed. So P is equal to P union that minimum label vertex, and T is equal to T minus V. Means we have to add this vertex into the permanent label vertex set, and we have to delete this vertex which is made as a permanent from the T, that is all vertices of graph G. If V is equal to Z, Z is our destination. So if minimum label vertex is become as a Z, then length of the then we have to stop, and that will be the length of the shortest path from the vertex A to Z, and we have to stop there. Step 3 is, if V is not equal to Z, means permanent label vertex is not as a destination vertex, that is Z, then revise the label of vertices of T. Means whatever vertices exist in the T, we have to give the new labels to that vertex, and for giving the new label there is this formula. So the new label of vertex X in T is given by Lx is equal to minimum from old Lx comma LV plus W, means weight from V to X. That is the formula for giving the new label to the vertices which is exist in the set T, where W v comma x is the weight of the edge joining the vertex v and x. If no direct edge, then weight will be infinity from v to x. Step 4 in this algorithm, repeat the step 2 and step 3 until z gets the permanent labels. So unless and until destination vertex is become as a permanent label, till that you have to repeat the steps 2 and step 3. Now this is the actual problem or actual graph where these are the vertices A and vertices Z. So it is a weighted graph. You can see that each and every edge given certain weight is assigned. So you have to find the shortest path between A to Z using the Discrete shortest path algorithm. If you see the Discrete shortest path algorithm, it will provide the shortest distances between each vertices from the graph along with the destination vertex. Now step 1, as per the step 1, so P is the set of permanent label vertex, so permanent is initially phi. T is all the vertices from the given graph, that is A, B, C, D, E, F, G, Z, F, G, Z. So initially LA we made as a 0 and T, and remove that vertex from the vertex set T after that. So Ls means all other vertices label we given as a infinity for all x belongs to T and x is not equal to A. So LB, LC, LD, LE, LF, LG, LZ, this will be infinity. Then label all vertices from vertex set T. So be aware with the formula. So LB is equal to, we have to give the label to all these vertices. LB is equal to minimum from old LB, comma LA plus the weight from A to B. So minimum from this is 2. LA is 0, that we know. LA is 0 plus weight from A to B. If you see weight from A to B is 2, this value is inserted here. So 0 plus 2 is 2 and minimum from this 2 is 2. Again in the same way we have to give the label to the S. So new label LC is equal to minimum from infinity comma 0 plus 4. So minimum is 4. In the same way LD will be 5. Then LE, LF, LG, LF, LG, LZ is infinity because there is no direct edge which is joining A to this vertex E, G, Z. Okay, so its label will be infinity. So LB is from this you have to select the minimum label vertex, that is B, and make it that label as a, or that vertex as a permanent label vertex, and add it into the set of permanent label vertex in the next step, that is in step 2. So LB2, this is permanent label vertex, and it is added into the set of permanent vertices, and it is subtracted from the T. Okay, so T will be changed and T is also changed. Now assign the new label to all vertex from the vertex set T using the formula. So LC is equal to minimum from, you are aware with that old LC is 4 here. So 4 comma permanent label vertex label is 2, 2 plus weight from that permanent label vertex, that is B to C. If you see B to C weight is nothing but 1. So that is taken, that is 2 plus 1. So it is minimum from this is 3. In the same way, we have to give the new label to the D, E, F, G, Z. So LD label will be 5, then LE is 5, LF is 3, LG is infinity if there is no direct edge between this B to G. there is no directly between B and Z, that's why it is infinity. Then select a minimum label vertex from this. The minimum label vertex will be here 3. It is by mistake it is written 1. We will see that 2 plus 1, so it is 3. So there are 2 vertices with the same label, so we have to select any one of this. LF is selected. Then LF is 3. It is by mistake written 1, but it is 3. So 3 P is equal to add this vertex into the permanent label vertex set, that is nothing but F is added into permanent label vertex set. So A comma B comma F. Then T is equal to, it is deleted from this set of T, so F is deleted from here. So C comma D E G E comma G comma Z is remaining. Assign new label to whatever vertex is present in the set T. So new label to the LC will be minimum from old LC is 3. Old LC is you can see that old LC is 3, comma new obtained label is 3. Here you should remember it is a 3 not 1. So 3 plus weight from F to C. F to C is a 2, and it is minimum from this 2 is 3. In the same way, label of LD will be 4, label of LE will be 5, label of G will be 7, label of Z will be 10. So select minimum from this, and minimum from this will be LC. So LC is equal to 3 as a permanent label vertex. Again we have to add that vertex into the permanent label vertex set, and delete that vertex from the set of all vertices from the graph G. So T and P will be changed. Then assign a new label to vertex in T. So same procedure is repeated. So we obtain LD is equal to 4, LE is equal to 5, LG is equal to 7, and LZ is equal to 10. Out of this, select the minimum label vertex as a permanent label vertex. So LD is equal to 4 become a permanent label vertex. Again apply the step 5. So in step 5, after assigning new label, so LE will be 5, LG will be 6, LZ will be 10, and LE is equal to 5, make it permanent. So this will be permanent because it is minimum among this. Then add it into the permanent label vertex set, and T, delete that vertex from the T. So again assign a new label to G and Z. So we will get LG is equal to 6 and LZ is equal to 8. Makes G as a permanent label vertex. Then add this G into the permanent label vertex set P, and delete it from T, and assign a new label to the Z. So it is 8, 6 plus 1, so minimum is 7. So 7 is a minimum label vertex because only one vertex is remaining, and it is a destination vertex. So here we have to stop because destination vertex we given a minimum label. So length of the shortest path is 7, and path is nothing but A, B, F, D, G, Z. This is the path. So A, B, C is skipped here because 2 vertices with the same labels, so we selected any one of this, that is D is selected. So A, B, F, D, G, Z. This is the shortest path that we obtain from the between the A to Z. So that's all about the shortest path algorithm. You can solve similar types of algorithm. So the just a shortest path algorithm is giving the shortest path between the source and destination, but along with this it also gives the shortest path